Welcome back everyone. Up to now we saw all the steps to tune, optimize and deploy the accelerator, so to generate the VHDL code that will be put on the FPGA. Now Spiker Plus also provides functionality to evaluate the functional behavior of this accelerator, to check if it is as expected and to synthesize the architecture. In this tutorial we will see how to test the functional simulation of the accelerator. Now that we run a full optimization step, we can select values for the bits that are the smaller possible. So as I mentioned before, 6 bits for the weights, 9 for the neurons and 5 for the fixed point decimals are values that allows to reach already a 93% of accuracy, so we will use these values. Let's remove the optimizing step, so we don't need it anymore. And now we can import the functionalities from Spiker Plus in order to be able to test and evaluate our functional simulation of the accelerator. We will work with the functional flag set to true, so we want to test the functional simulation, and with the interface set to false, so we will evaluate the raw network. And then we can instantiate the simulator, specifying the VHDL description of our spiking neural network. And then we can run the simulation step, selecting the set of data on which to evaluate the accelerator, that again, as in the case of the optimizer, will be the test loader, and specifying the duration of the simulation. In this case we will specify 200 microseconds in order to guarantee a full execution of the inference process on the accelerator. If we now run the code, you will see all the previous steps: the compilation of the accelerator, the elaboration of all the components, and then the simulation will start. It will periodically print the expected result for the label that is corresponding to the input data and the classified result, so you can also already check if they are equal as expected. After elaborating a bunch of data, the simulator will print a summary on the total accuracy reached on that set of data. In this case you see 80%, because over 10 data it classified correctly 8 of them. If we run the simulation for the full set of data, the value of the accuracy will tend to the 93% we observed on the optimizer. The amount of data after which this information is printed is configurable. In this case it was set to 10, but you can set the value depending on the computational power of your platform and the precision that you want to reach on the accuracy estimation.